Hello everyone, now we will have a tutorial session and in this class we will solve some numerical problems based on the discussion we have made in the last 4 classes. Problem number 1, the statement is find the specific gravity of sludge if it contains 70% volatile solids with specific gravity 1.7 and remaining non volatiles with specific gravity 2. Moisture content is 98%. This is a problem which deals with the characteristics of sludge, basically how to find out the specific gravity of sludge we have discussed in our previous class, and on the basis of the same concept we will solve it. So, the sludge had solid and that solid is basically two types as given here in the statement. One is non volatiles and another is volatile, and volatile solids has a specific gravity which is different from that of the non volatile, and the values are also given. Okay. Again it is also given that volatile solid is 70%. Okay. So, non volatile solid will be 100 minus 70. So, percentage volatile solid equal to 70 and percentage non volatile solid is equal to 100 minus 70, that is equal to 30, and specific gravity of volatile solids it is given 1.7 and specific gravity of non volatile solids it is given 2. So, this is 2.7. Okay. The specific gravity of non volatile solids equal to 2.7. Now, how to solve this problem? We have discussed in our previous class that the formula will be like this: the 100 by specific gravity of solid, that is equal to percentage volatile by specific gravity of volatile plus percentage non volatile by specific gravity of non volatile. So, this we have discussed in our previous class. So, in this case if we see the percentage volatile is equal to 70. So, if our basis is a 100 gram of solid, then 100 divided by specific gravity of solids. So, this is the volume of the solid, total solid. So, here percentage volatile in mass divided by specific gravity of volatile. So, that is the volume of the volatile part of the solid, and percentage non volatile divided by, this is by mass and then specific gravity of non volatile. So, this will again the volume of the solids of non volatile in nature. So, this total volume will be the volume of the this total solids. Okay. So, this is the basic equation. So, here we will put the values. So, 100 by specific gravity of solid, then we are getting 70%. So, its basis is 100 as you have mentioned here. So, this percentage will be 70 here, and specific gravity of volatile is 1.7, it is given, and non volatile we are having 30%. So, that is this percentage non volatile is 30, and in this case the specific gravity is 2.7, it is given. So, we are putting this one, or the specific gravity of solid is becoming 1.912. By solving this expression we are getting 1.912. So, what we have got, that is the specific gravity of the solid, okay. But now we have to calculate the specific gravity of the sludge. So, again in the sludge we have solid and we have water. So, the specific gravity of the solid part we have got it here, which is composed of two types of solid, that is volatile and non volatile, and that overall is 1.912 we have got. Then we will be considering for the sludge, we will be having one solid part, another your liquid part, that is water. So, in that case again the same type of formula we will use, considering total solid and water. Okay. So, 100 is the slurry, then or the sludge, then specific gravity of sludge, 100 is a weight, we are considering the 100 gram mass. So, 100 by specific gravity of sludge, total volume of the sludge, that is equal to percentage solid by specific gravity of the solid. So, that is the volume of the solid present in the sludge plus percentage water divided by specific gravity of water, the volume of water present in the sludge. So, this will be equal. So, this is the concept. So, here 100 by specific gravity of sludge, that is equal to percentage of solid is given, that is 98% water. So, 2% is your solid. So, that is 2 and divided by specific gravity of solid, just we have calculated 1.912, and then percentage of water is equal to 98 and specific gravity of water is equal to 1. So, this is the expressions we are having, and from this, by solving this expression, the specific gravity of sludge is becoming as 1.009. So, now we are able to solve the problem. Now, we will see problem number 2. The statement is, a sedimentation tank is treating 4.5 mld of sewage containing 275 ppm of suspended solids. The tank removes 55% of the suspended solids. So, calculate weight of sludge produced per day, assuming moisture content of the sludge as 96%, and second is, if specific gravity of the sludge is 1.02, calculate the sludge quantity in bulk. So, this is the problem statement and we have to solve it. So, how to solve it? You see, the flow rate is given, that is the sewage flow rate is 4.5 mld and it is allowed to settle in a sedimentation tank, and the sewage is having 275 ppm of suspended solids, and it is also given that 55% of the suspended solids will be removed. So, if we have a tank, so 55% of the solid will be coming here. Okay, so, what flow rate we are having Q, it is having some CO. Okay, so, total solid present in it we can see, and 55% of that solid is coming here. So, now we can calculate what was the amount of solid that is coming here if we maintain the same flow rate, and for the same flow rate what will be the 55% of solid present in that sewage. So, that solid part will be settled here. Okay. So, let us see Q is equal to 4.5 mld, the million liter per day, and then C solid 275 here. So, 275 mg per liter. So, concentration of solid produced as sludge. So, that is equal to, we have to calculate. So, that is equal to how much? So, 55% removed. So, 0.55 basically. So, 55 by 100 into 250, that is equal to 151.25 mg per liter. So, if we assume that volume remaining same, only some solid is settled. So, 55% is settled and remaining 45% is available with the water in the with the sludge. This part 45% is present here and 55% is present here, say. Now, if we take the total volume and if we take this formula, that is 275 into 55 by 100, that is 151.25, that will be the concentration of the total volume or the volumetric flow rate that is being settled. Okay. So, now this is the, that will be the concentration of it. So, if we multiply it with this total volume, that is 4.5 into 151.25. So, then that is the value which will be getting, that will be the dry mass of solids in sludge. So, in the sludge that is being settled here. So, that will be Q into concentration of solid in sludge, that is equal to this one, sludge means in this case. Okay. So, 4.5 into 151.25, that is 680.625 kg per day. So, this is the first part, weight of sludge produced per day, assuming moisture content of the sludge as 96%. Now, we have not considered this one 96% moisture content, this is the total solid in sludge we are getting. Now, we will be considering the percentage of moisture, that is water 96%. So, what will be the volume of the sludge containing both solid and the water. Okay. So, then mass of sludge produced per day will be how much? 100 divided by 100 minus P into m, where this 96 is your water content. So, remaining 100 minus P, that is equal to solid. So, if solid is this much, so remaining will be water, and then total sludge will be this one 100. So, 100 divided by 100 minus 96 into that how much solid is produced, that is 680.625. So, then by this expression, by solving these expressions, we are getting mass of sludge produced per day, that is equal to 17015.625 kg per day. Okay. So, this is the mass of sludge produced per day. And then second part, if specific gravity of the sludge is 1.02, calculate the sludge quantity in bulk. So, we have to divide it by 1.02, then 1.02, then we will getting the 1.02 is your specific gravity. So, if you want to get the density, so that will be, we have to multiply this sludge specific gravity with the density of water. So, we are getting 1020 kg per meter cube. So, directly we can divide it 17015.625 17015.625 divided by 1020. So, that will also give us 16.68 meter cube. Okay. Or alternately the same formula, that is this one 100 minus P into m by rho of sludge. Okay. The sludge quantity will be actually this formula. So, this part we have already calculated here, dividing it by this. Alternately, we can put this value also in this expression, and we can get the value of 16.68 meter cube. Okay. So, now, so the problem is solved now. Now, we are going to problem number 3. The statement is the water content of solid slurry wastewater sludge is reduced from 98 to 95%. What is the percent reduction in volume, assuming that solids contain 70% organic matter of specific gravity 1 and 30% mineral matters of specific gravity 2? What is the specific gravity of 98 and 95% slurry? So, this is another problem of similar subject, that is sludge, its characterization, and basically it is related to treatment. Okay. So, how to solve it? So, here the sludge initially is having 98% water, and that water content is reduced to 95%. Okay. Due to this reason, the percentage reduction in volume we have to calculate when 75% organic matter in the sludge and 35% is mineral matters, and their specific gravity are also given. So, we will be using the similar type of expressions which we have used in our previous problems and discussed in previous classes. So, here for the first case, say water 1, for water in case 1, that is equal to 98%. So, 2% is solid, and water in second case W 2 is equal to 95%. So, 5% solids, and this increment of solid 2 to 5% is taking place in the process. Okay. This solid content is increased due to dewatering process. Now, if we consider W solids by S solids into rho W, then that will be the volume of the solids basically. So, that is equal to two types of solids we have, that is mineral matter solid W mineral divided by specific gravity of mineral into density of water. So, that is again the volume of the solids of mineral matters, and then W organic matter divided by specific gravity organic matter into rho W. Again this is the volume of the solids due to organic nature. So, then these two will be the total volume, the same formula we are using now, and here S is the specific gravity, W is the weight, and or you can say mass. So, rho W is the density of water 1 kg per liter. Basically this is mass, and then now what we will see, water content in the case 1 98% already have discussed, organic matter content 70%, that is if W solids is total solids, then 0.7 into W solid will be the organic matter content, and then mineral matter 30% of that, that is 0.3 into W solids, and rho W 1 kg per liter, and S mineral, that is specific density of mineral is equal to 2 or specific gravity of mineral is equal to 2, and S organic matter, that is equal to specific gravity of organic matter, that is equal to 1, it is given. And now in the previous expression we will put it here, the values for determining specific gravity of all solids, that is W solids by S solids, that is equal to, now this mineral matter, that is equal to 0.3 W solids divided by rho solid of it, that is equal to 2 into 1, that is water. So, that is equal to this one, and the second is we are getting 0.7 organic matter divided by your rho S mineral, that is equal to 1 into rho water, that is again 1. So, these expressions we are getting, and by solving this we will be getting 1 by S solids equal to 0.15, because W solids equal to 1 we are considering, in that case total solid is 1. So, that is 0.15 into, that is equal to 1 by S solid is equal to 0.15, this part 0.3 by 2, and this is 0.7 by 1. So, 0.7. So, then is equal to 0.85. So, S solid is equal to 1 by 0.85. So, 1.18. So, this is the specific density of the solids in the first case. Now, if specific density of water is 1 and water content is 98%, it is given. Okay. So, solid content in this case is 2%. So, we can calculate the specific gravity of sludge, not solid, for 98% moisture, that is equal to 1 by specific gravity of sludge, that is equal to solid content in the sludge divided by specific gravity of solid sludge, solid of solid plus water content of the sludge divided by specific gravity of water. So, water content is say 98%. So, if it is 1, total sludge is 1. So, 0.98 is water. So, divided by 1 and plus 0.02 is total solid. So, that is divided by the specific gravity we have calculated here 1.18. So, this by solving this expression we are getting 1 by S sludge, it is equal to 0.9969, or S sludge is equal to 1 by 0.9969, that is equal to 1.003, or density of sludge is equal to 1.003 into 1. So, 1.003 kg per liter. So, this is for case 1, and for the second case, specific gravity of sludge when 95% moisture is present, again the same formula we will use, 1 by S sludge equal to, in this case this is equal to 0.95, that is moisture, by 1 plus 0.05, that is the total solid, divided by 1.18. We are considering that 30% and 70%, that ratio is remaining same in both the cases. So, here we will be getting that 1 by S sludge is equal to 0.9924. So, this S sludge is equal to 1 divided by 0.9924, that is equal to 1.007, or density of sludge is equal to 1.007 into 1, that is 1.007 kg per liter. Now, we will be calculating volume of sludge. So, volume of sludge is mass of sludge divided by density of sludge. So, for 1 kg of solids, the volume of sludge will be 1 kg by solid content, that will be the total amount of sludge divided by density of sludge. So, that is the formula we are using here, 1 by solid content into density of sludge, this one. So, in this case 1 by solid content is 0.02 in the first case and 1.003 in the density of sludge. So, we are getting this expression that volume of sludge for the first case is 49.85 liters. Okay. So, for the second case, when we are having 95% water, so this the volume of sludge for 1 kg mass of solid, we are getting the same from the same formula 1 by 0.05 into 1.007. So, that is equal to 19.86 liters. So, percentage volume reduction is equal to how much? That is 49.85 minus 19.86 divided by 49.85, that is equal to 1 minus 19.86 by 49.85 into 100. So, that is equal to 60%. Okay. So, now we are able to solve the problem. Then problem number 4, statement is using the following primary settling tank data, determine the daily sludge production. Operating data are given, flow 0.10 meter cube per second, influent suspended solids 240 mg per liter or 240 gram per meter cube, removal efficiency is 69%, sludge concentration 5%, volatile solids 60%, specific gravity of volatile solids 0.990, fixed solids 40%, specific gravity of fixed solids 3.65. Okay. So, this is the problem statement, we have to solve this. So, now let first calculate specific gravity of solids, the same formula we will be using. So, how can we get it? SS is equal to MS into SF SB by MF SB plus MV SF, where MF is the mass of fixed solid, MV is the mass of volatile solid, MS is the mass of solids, total solid, and SB is the specific gravity of volatile solids and SF is the specific gravity of fixed solids. So, now what we will do, say S is equal to the specific gravity of solids, that is equal to mass by volume. Okay. So, mass equal to say MS and volume of what? This MS is the total mass of the solids. So, that will be the sum of the mass of fixed solid and volatile solids. So, now how we will get it? What is the volume? How can we get it? So, MS MF mass of fixed solid divided by SF plus we are getting MV mass of volatile solid divided by SV. Okay. So, this is by definition of this specific gravity. Okay. So, this equal to this one, or by rearranging what we are getting this expression, we are getting. So, MS into SF SV at the numerator and denominator MF SV this term and MV SF this term. So, this term has come from this basic expression. Okay. So, now SS is equal to this one and MS is equal to total mass, that is MF plus MV. So, we are assuming that is 1. So, MF that is 60% and 40%. So, 0.6 will be for fixed solids and 40% that is 0.4 is equal to our volatile solid. Okay. So, this is the condition it is given. So, what will be the SS? Then we are having SF, SF value is given. What is the SF? Specific gravity of fixed solid, that is 3.65 it is given, and then specific gravity of volatile solid 0.990 it is given. So, this value is given, and MF that is equal to 0.4 into SV 0.990 plus MV 0.6 into we are having 3.65. So, these expressions we are getting, and SS is coming as 3.613 divided by 2.586, that is equal to 1.39. So, now we are getting the specific gravity of the solids. Now, we have to calculate the specific gravity of sludge. Now, for this calculation again we are considering the Ps is the fraction of sludge and Pw is the fraction of water. So, the same concept we will be using. So, the specific gravity of sludge SSL, that is equal to SS divided by Ps plus SS by Pw. So, again if you write say 1 divided by Ps by SS plus Pw by 1. Then now, if you say that 1 unit of mass of the slurry, that is the sludge. So, that is equal to 1 divided by fraction of sludge, that is equal to solid fractions. So, sludge, that is rho s, and then divided by SS, that is solid, and then water remaining, that is equal to Pw fraction of water and divided by density of water 1. So, again the same formula which we have discussed in our previous problem also and this problem also. So, we are getting by this. So, by rearranging these expressions we are getting this one. So, SSL, that is specific gravity of sludge, will be calculated by this formula. So, 1.39 we have got, and then Ps is equal to, it is given, that is the fraction of sludge equal to sludge concentration 5%. So, 0.05 it will be coming, and then SS we have calculated 1.39 into Pw. So, 5% solid. So, 95% is your water. So, 0.950. So, that is equal to 1.39 by 1.37. So, 1.019. So, this is the specific gravity of the sludge. Now, the mass of sludge is estimated from the incoming suspended solids concentration and the removal efficiency of the primary tank. So, how much solid will be removed in the sludge, that we can calculate on the basis of this expression. So, here efficiency is 69% and this is your volumetric flow rate and this is your concentration of the solids. So, this is and this is the efficiency. So, that will be per second. If you want to convert it into per day, so you have to multiply this, and there is some unit conversion. So, you have to 10 to the minus 3 kg per gram. So, then we are getting MSL is equal to 1.430 into 10 to the 3 kg per day. Then the sludge volume can be calculated like this: VSL is equal to MSL MS divided by rho into PS into SSL. Okay. So, that is equal to 1.430 into 10 to the 3 MSL we have got, and that is rho is given 1000 kg per meter and SSL 1.019 we have calculated and PS solid content 0.05. Then from this expressions we are getting this equal to 1.430 into 10 to the 3 divided by 50.9. So, that is equal to 28.1 meter cube per day, where MSL is the mass of sludge and rho is the density of water. So, now we are able to solve this problem. Next problem 5, the statement is 200 meter cube of mixed sludge at 5% solids is to be thickened to 10% solids. Assuming the specific gravity is not appreciably different from that of water and it does not change during thickening, what is the approximate volume of the sludge after thickening? So, this is also a problem related to the thickening process. So, we will see the mass balance of this, and if we have a thickener. So, here mixed sludge we are having volumetric flow rate it is given and then concentration is also given. So, we are assuming that in the supernatant the concentration will be C3 and V3, and here in the thickened sludge the V2 and C2, that is C2 is 10% and V2 we have to calculate what is the approximate volume of the sludge after thickening. And in this case we can assume that after settling the supernatant which is going out, that will not have any solid content, that assumptions we will take. Say a 5% sludge contains 5% by mass of solids and 95% water by mass, we can approximate the relationship between volume and percent solid based on a mass balance around thickener. The mass balance diagram is like this, and in this case what we will get, this C1 V1 equal to C3 V3 plus C2 V2 in equilibrium, or C1 V1 minus C2 V2 minus C3 V3 equal to 0. Now, if we put that C 3 is equal to 0, so that C 3 V 3 term will be 0. So, C 1 V 1 is equal to C 2 V 2, okay, or V 2 is equal to C 1 V 1 by C 2. Now, we will be putting this value, what is the C 1 and what is the V 1, V 1 200 and 0.05 is C 1 and C 2 is equal to 10%. So, 0.1. So, the V 2 will be 100 meter cube. So, we are able to solve the problem with the assumption that C 3 will be 0. So, up to this in this class, thank you for your patience.